So 8.6 is learning just to solve. We've done a little bit of it, but we're just going to get more practice of solving exponential and logs. 8.2, I think it was, maybe 8.3, was talking about the common base, which is the lesson that you guys loved. Remember getting the common base, or reducing it down to be the common base and setting the exponents equal to each other? Y'all loved that. So that would be like the one that we just did, 8 to the x equals 4, and then reducing it. That's a common base example, like when you have them both equal to each other. Yes? Okay. The second method is when you don't have a common base. So when you don't have a common base, we are only going to do method 2b. So mark out 2a. I think that's the method that Roman's tutor tried to teach him. He's not even listening to me. It's okay. I think he's sleeping during his quiz. Okay. We're not going to do that. That is an old, kind of, not outdated, but back in the day when I was in high school, calculator didn't have the function to have a different base. So it only did base 10s. So we would use method 2a. But we're going to do 2b. So rewrite the equation with one term on each side. And then we're going to rewrite it as a logarithm and solve using the properties of logs. And so this just takes some examples to get to know what I'm talking about. So even like the 2a, 2b thing, you can just cross those out. I don't really like all that. We're just going to solve it the way we know how. So if you have 2 to the x equals 5, then I'm going to rewrite this as, I'm going to change it to logarithmic form. Log base 2 of 5 equals x. And I'm just going to leave it like this. Now, if you put it in your calculator, you'd get some funky decimal, but I'm just going to keep it like this. I don't want to see all of the decimals. I just want to know that you know how to solve it. Now, number 2, if you have a number in front, what do you need to do with that? You need to divide it out. Because you want to get it in exponential form first, which is like 3 to the x equals number. This right here is exponential form. You want it to look like this before you can convert it to a log. So if anything is standing in the way, like if there's a plus or minus, or if there's a coefficient in front, then you must divide it. So 3 to the x equals 5/8. I'm going to convert it to log form. Log base 3 of 5/8 equals x. And I leave it like that. Okay, so in number 3, this one is a little bit different because you have 2 numbers that have different bases and different exponents. Is there any way to make the 5 and the 3 be the same base? There's no way. So this is like a special case. And this would be a problem that makes this class pre-AP. It's pretty difficult. So this one is like a special case. I want you to star it because it might show up in the homework or something, and it's something that's kind of different, that gets its own special rule, I guess. So when you have 2 numbers set to exponents that are not the same, like you can't make them the same base, you would rewrite it using the log properties. So what you do is you can either take the log of both sides or the natural log of both sides. And I usually use the natural log. So I'm going to rewrite this as, I'm going to take the powers and they're going to jump out in front. And I'm going to rewrite this as x minus 2 natural log of 5. So what I'm doing is, so this is when bases cannot be the same. Take natural log of both sides. So this is kind of like a 2A, method 2A technique. And that equals 3x plus 2 natural log of 3. Now, if you wanted to write this as, like, you're just a log person, you could put log of 5 and log of 3. They can be used as the same thing in this case, but I use natural log. So then you want to get x by itself. So I'm going to distribute this natural log of 5 to both terms and distribute the natural log of 3 to both terms. So I rewrite this as ln of 5 times x minus 2 ln 5 equals, then I distribute the right side, 3 ln of 3 times x plus 2 ln of 3. The next step is I want to get all of my x's on one side. So I've got an x here and I have an x here. These two things are considered to be constants. So I want to get all of my x's on one side and I want to get all of my constants on another side. So I'm going to move the 3 ln 3 of x to the left, and I'm going to move my 2 ln of 5 to the right. So I rewrite this as ln 5 x minus 3 ln 3 x equals 2 ln 5 plus 2 ln 3. Uh-huh. From there, I'm going to pull out, they both have an x in common. So I'm going to take that out. So x, actually I'm going to write this over here. Sorry I did not give you guys enough room. So x ln 5 minus 3 ln 3 equals 2 ln 5 plus 2 ln 3. I'm going to show you what we're going to do here in a minute with that. From here, we're going to use our 8.4 rules, or I guess 8.5, to condense. We're going to condense the left and we're going to condense the right into being one natural log. So condense and condense. So how would I condense the left? If you have a minus, what does that mean? It's on the denominator. So 5 goes on the top, and what goes on the bottom? 3. But there's a 3 in front of it. So 3 to the third. And I'm going to condense the right. What goes on the top? 5 squared and 3 squared, right? No, they're all together. Sorry, they're all together. Times, can't. And x, natural log of 5 over 27 equals natural log of whatever 5 squared times 3 squared is, 25 times 9. You got that, Claire? 225. One last step, divide each side. I know. Goes away. And you can leave your answer just like this. So natural log of 225 divided by natural log of 5 over 27. Do what? So if you had this without a calculator, I wouldn't put a number like 225 in there. It would be a number smaller. But this could potentially be a problem without a calculator. Yes. So going through the steps again, just kind of put your pencils down and watch me. Going through the steps, take the natural log of both sides. From there, it's like it is just algebra. I mean, just like solving an equation. So take the natural log of both sides. So that's step number 1. Step number 2 would be distribute. Step number 2. Step number 3 would be get x's on one side. Step number 4 would be pull out the x. So you missed step number 2. Step number 2 is distribute. Step number 3, get x's on one side. Step number 4, actually step number 4 is pull out the x. 5 is condense. And then 6 divide. And you're left with the answer. Okay, number 4. I know that is, we don't have a lot of room. So I'm going to rewrite it down here. 500 e to the 0.3x equals 600. It's not in exponential form yet. What should we do? Divide by 500. So you get 6/5. Now anytime you have an e, is it smarter to take, like put it in log form or put it in natural log, like ln form? ln. So I can rewrite this as, if I take the ln of 6/5 equals 0.3x. So basically, if I were to put it into logarithmic form, it would be like log base e of 6/5 equals 0.3x. Because the e just comes down. But then I'm rewriting log base e as ln. So you can start off with log base e and then switch it to ln if you don't want to make that jump. And then whenever you have a decimal, and this showed up on the homework too, I think it was like 0.2 or something on the homework. Before I divide by a decimal, I want to rewrite this as a fraction. So what can I change 0.3 to be? 3 over 10, right? So I'm just going to say that this is 3 over 10x. And if I want to get x by itself, so move it to the right, what do I multiply to get rid of this 3 over 10? 10 over 3. I know that it's hard to see, sorry. Should have more room. So my final answer would be 10 natural log of 6/5 over 3. And the 6/5 stays attached to the ln, and it doesn't get mixed in with the 10 or the 3.